Let's talk about Chapter 10, Characteristics of Plastic Materials. Plastics are engineered materials that can be formed and molded into useful shapes. Most plastics are petrochemical based, so they come from crude oil in some way. Some newer plastics are being developed that come from plant sources like corn or sugar beets, but the vast majority of plastics come from the ground, from crude oil. Some advantages of plastics are their lightweight. So a typical plastic weighs 1/8 as much as steel. So in a lot of situations, this is very helpful. You don't need the weight or the complexity of steel parts when plastic would work just fine. In the automobile industry, they've really taken advantage of this in reducing weight on a yearly basis of cars just by replacing things that were steel with plastic. Plastic is corrosion resistant. So different plastics have different properties, but for the most part, they're more water resistant than something like plywood. They don't rust like steel does. Some things can stand chemicals better than steel or wood or other materials. The downside with the corrosion resistance, I'm sure everybody's heard that a styrofoam cup will last 1,000 years in the ground before it degrades. The reason is it's corrosion resistance, right? If you threw a sheet of plywood in the ground for 1,000 years, it'd be gone in a week or it'd be gone in a year or so, right? Plastics have good thermal and electrical insulation capabilities. So before plastic sheathing on wires, they used different kinds of fabrics. They were heavier and they weren't as good as plastic. Plastic is cheap and plentiful for many things where things need to be insulated. And plastic can also be easily formed to have a smooth reduced friction surface. Whereas things like steel and wood can be made to have a smooth surface, it's a lot more work to get there than it is plastic. Plastic can just be put in a form, molded, and it's basically friction-free forever. Plastic was really invented in the 1800s. The first really useful plastic was something called celluloid. Celluloid was used for many different things, but one of the main ones was film stock. So early cameras used film made out of celluloid. Celluloid is a useful material, pretty strong, pretty easy to make. The downside being that it was extremely flammable. So there's stories of, newspaper articles of film houses just spontaneously combusting because the celluloid was so flammable. So anybody that stores old film has to take special precautions because of the celluloid. Bakelite was invented in 1907. It's made from phenol and formaldehyde. Bakelite was extremely useful and popular up until the World War II era. Basically anything made out of plastic before the 1950s was bakelite. As we'll talk about later, bakelite is a thermoset plastic, which basically means it can't be melted back down. So that means it's basically not recyclable. Bakelite isn't particularly popular anymore, but it used to be, and it was used for just about everything before these companies like 3M came up with new materials. So let's talk about making plastic. Plastic comes in the form of resin. Resin is just the raw material. It could be powder, it could be granules, it could be little pellets, it could be a liquid like fiberglass. This resin is used to make the plastic, which we'll talk about next week. All the different ways they melt it and form it or bend it into some useful product. Two major categories of plastics are commodity resins and engineering resins. There's kind of a loose difference between the two, but things that are commodity resins are usually made to be sold to the general public. So things like milk jugs or plastic bags, right? Those would be your commodity resins. They're typically lower performance, easy to make, and cheap and plentiful. Whereas engineering resins are going to be more high performance and specifically designed to do certain things. So the plastic that they use in something like a football helmet is made to be strong, impact resistant, and absorb shock, right? Things that are made for spacecraft are designed with specific thermal properties so they can stand the temperature changes. So let's chat about the structure of plastics, what's going on inside. All plastics are made of things called monomers. Monomers are just little groups of atoms with a particular array. These monomers are going to join in either chains or cross-link chains to form polymers. Polymer and plastic are usually used basically interchangeably, but a polymer is just a collection of monomers. The process by which monomers become polymers is called polymerization. There's two kinds of polymerization, but either are going to use a combination of heat, pressure, or a catalyst to convince the monomers to join together and become a polymer. Addition, polymerization, is going to join the monomers in long chains. Addition polymerization is a process that joins the monomers in a non-chemical way. So their atoms are not going to share bonds. These are going to be typically thermoplastics. They're going to be easily melted, and it's easy to change the shape because the chains of monomers can kind of just slide right by each other. The other kind is called condensation polymerization. Condensation polymerization is going to form atomic bonds between the monomers and something called cross-linking. This cross-linking is going to stop the chains of monomers from moving around. What this results in a macro level is something that can't be easily bent when it's reheated. So these materials are typically going to form our thermoset plastics. So once they've gone through polymerization, they're basically stuck forever. They can't be reheated and cast again. They'll just char or burn. The two major classes of plastics, and you'll see this if you ever have to go through a plastics handbook to order something, are thermoplastics and thermosets. Thermoplastics make up the vast majority of the plastics out there, including most of the commodity plastics, so things you use every single day. They're typically not as high performance as thermosets. They're not particularly strong, but they're useful enough for what they do. One important thing to know about thermoplastics is that they can be heated and reformed, or they can even be melted and recast into something useful. What this means is that they can be recycled. So that's a good thing. You can take a bunch of milk bottles and melt them down and make new milk bottles. Thermosets, because of their cross-linked polymerization, cannot be reheated and reformed. Once they've been formed, they're stuck. So these materials are going to be more difficult, although not impossible, to recycle. If you've ever seen a fiberglass boat, right, after you take the engine out, there's really nothing you can do with it besides send it to a landfill. That material cannot be recycled.